Today we're looking at derivatives of exponentials. We looked at derivatives of basic functions, and we also looked at derivatives using the quotient rule, the product rule, and the chain rule. We're now looking at derivatives when it relates just specifically to exponentials. And just like when we do derivatives with our basic functions, we have certain rules that we have to apply with. However, when it comes to exponentials, these rules are a little bit different to what you're regularly looking at. Some look similar to a chain rule, but overall, they're a little bit different. So if we look at the examples we got up here, if we have a function which equals y is equal to e of x, then the derivative of that function is just e to the x. If we have a function where y is equal to e and a function other than x, then the derivative of that is the exact same function, but then we multiply by that derivative of that function of x. It looks a little bit complicated, but it is nice and straightforward, and once you get used to the skills that we're doing with it, it does become a second nature kind of calculation. When we are working with exponentials, we do want to make sure that we're writing things with a positive indice, okay? And a lot of times when you start working with exponentials and logarithms, you'll be expected to leave your answer in that form if possible. And they usually just state in questions, leave it in an exact form. And leaving it in an exact form is leaving it with an exponential as part of the answer or a natural log. But let's get into some examples so you can see how these are done. And then straightforward calculations that you have to go over for yourself. So we've got some examples over here. We've got some work that we can go through. So let's get into it. So the first one we got here is f of x is equal to e of the x plus 3. Now if we look at our rules up here, anytime you have e to the x by itself, then we rewrite that. So the derivative of this would be e to the x. And we know that a derivative of a constant would just give you 0. So therefore, that's the only answer that we get. If we have a look at the second one, this is where some students get mixed up, okay? One of the errors that students make here is they'll do something that looks like this. E to the x to the power of negative 2. You cannot do that, okay? We can't bring this up and make that negative 2 because it's not a function down here of x. So what we can do is have a look how this is written. What's another way I can write x on 2? Another way I can write this is write it as e to the power of half x. And then once you really get used to the understanding that this means the same thing, then you won't have to worry about changing that any further. And the reason why I'm showing you this part here is because you know how to differentiate something that looks like that. If you had 3x and you wanted to differentiate that, well, you know that this just becomes 3. The same thing will apply here. So we're now ready to differentiate. Let's differentiate. So we write down the exact same function. Now I'm going to write the exact same function I had up here. So e to the x on 2, and then I'm going to multiply it by the derivative of this f of x here. And the derivative of this f of x is just half. Now you can leave your answer like this. However, in some cases you may have to simplify it. So therefore your final answer here will become 1/2 e to the x, or we could rewrite it as e to the x on 2 over 2. Okay, so either the answers are going to be give you the same results. Most times you might see it written in this part here because you multiplied this across with 1. Alright. Let's have a look at the next one. So the next one is e to the 1 on x. Now the reason why I've chosen this one here is because it looks similar to the previous one, but in this one we do want to raise it up and make it to a power of negative 1. So before we do any differentiation, let's rewrite it so that way we've got everything that we need in terms of derivatives. And it's from this point here we can now differentiate. So again, I'm going to write the original function down. It's equal to e to the half x, and then I'm going to multiply it by the derivative of this. And the derivative of this here is going to be x to the power of negative 2 times by negative 1. Okay? So I could bring it across and maybe bring it over here and say, let's put -1 here. And there's nothing wrong with that. Okay, so we've now got our calculation. Again, you can leave it like that. However, remember I said right at the beginning, we don't want to have any negative indices. So we can rewrite this down as e to the power of 1 on x all over x. Remember, this is negative here because a negative times a positive is going to give you that negative 2. Okay, so this here is our considered final answer when we have positive indices instead of negative. Okay. Could you leave it like this if it's asking you to solve without simplifying? It could, okay? However, get into the habit of getting rid of these negative indices because they're going to make life much easier for you when you are using applications of these calculations. And one thing you should notice is we're leaving it in an exponential form. We're not trying to solve for e. Next one. Y is equal to 10, 1 minus e to 2x. Alright, looking at this question very carefully, one could look at it and say, you know what, that's a product rule. It's not a product rule, even though we've got two things multiplying. If I had this as a product rule, then I'm going to get a 0, and I'm going to get an unsatisfactory answer. So in this case here, if you've got a constant and you have a function behind it, let's expand that through first. So again, before we do any differentiation, let's expand all our calculations so we've got what we're looking for here. No, that should be plus. Is it? It should be plus, and we've got plus there. So plus. Yeah. Alright. Now, one thing that you want to do at this point here is some students sometimes they differentiate and then expand. You don't need to do that. All right. Do everything you need to do beforehand and then differentiate it all in one operation. So we're now ready for differentiation here. So we know that the constant is going to be 0. So I don't have to put a 0 there. I can just leave it the way it is. What I do know is I can differentiate this. So this here becomes 10e to the 2x, and I'm going to multiply that by 2 because the derivative of 2x, according to our rules here, is going to give me 2. Unsimplified version, but we really want to try and simplify this up, so we get 20e 2x, which is your final answer for this type of question. Alright. Let's now get into this one here. First thing you should notice is this here is a product rule question. Okay, we've got two functions that are multiplying with another. The second thing you should be noticing here is I've got negative x. That is different to x. Okay, so we do need to find the derivative of this function. We can't just rewrite it as e to the power of negative x. Okay, it only works e to the x. Because it's a product rule, we know that we're going to have a u function and a v function. So u is going to be x cubed u dash 3x squared. V is going to be e to the negative x, and v dash is e to the negative x times by negative 1. And that gives us a simple form, if you want to, just negative e to the negative x. Okay, so I like to simplify in this form here because it makes life a little easier when I start to multiply to know that I'm carrying through that negative. You can leave like this if you like as well. We're now ready to differentiate or put this all together. So we know it's a product rule, so it's a product of the inside plus the product of the outside. So the product of the inside is 3x squared e to the negative x. The product of the outside, well, I'm now going to use a minus. And the reason why I'm going to use a minus is because this minus sits here. So I'm going to get minus x cubed e to the negative x. Okay. Now if we look at these types of calculations here, what do we notice? We still have some negative indices, and we need to get rid of those negative indices. And we've seen in the previous example, for this example here, that anything that's negative comes down as the denominator. So Could we leave this like this? You could have the same without simplification, but get into the habit of rewriting this so that way you're working with values that are in positive nature, because it's easy for you if you're going to plug into your calculator to forget it's negative. You may have accidentally pressed it, may have accidentally not pressed it, therefore you get an answer, but it's not the answer you're looking for. And this here is your final result that we're looking for in this calculation. Next one. Y is equal to e to x over x. Okay? Again, different to what we had in the previous one. This time it's got e to the x, so it's going to be exactly the same. Again, we're using a rule, which is the quotient rule. So we've got our u and then we've got our v. So u is equal to e to the x, u dash is equal to e to the x, v is equal to x, and then v dash is equal to 1. And just like the product rule, it's the product of the inside, but this time remember it's minus the product of the outside divided by the bottom squared. So dy dx is now equal to x ex. Okay? And we generally write in that way because this looks a little bit neater. Okay? And then minus e to the x, because 1 times that gives me that, all over x squared. Now, we generally can just leave our answer like that. Okay? You can simplify by factorising e to the x out and going a little step further, but a lot of the times this here is acceptable because if we're going to do an application in it, it's easier to do it that way anyway. And that's it. So that's your quotient rule with exponentials, using the quotient rule. Alright, so our last one here. Y is equal to 1 on 2 minus e to the minus x. And we're saying when at x is equal to 0. What do we notice about this question first? Well, what we notice is we've got a function that's below 1. So I have to bring that function all the way up. So I now have y is equal to 2 minus e to the negative x, all to the power of negative 1. And that's what I'm looking for in this case here. I've now got a chain rule. And we know the chain rule is going to be bring the power down and then multiply by the derivative inside the function. So we're now ready to start differentiating. So we get negative 2 minus e to the negative x, again to negative 2, and now we're going to multiply it by this. So if we're looking at this calculation here, what we've got is we've got negative e to negative x multiplied by negative 1. Okay? Really important that we include that negative because it's part of that term. We can rewrite this if we like to negative 2 minus e to negative x to the power of negative 2 plus e to the negative x, because we're going to get a negative times a negative. Okay? What we have now is we've got a calculation that we could substitute x into it and make get our result, or we can make life easy for ourselves and rewrite it. So we have negative e to the negative x over 2 minus e to the negative x all squared. And personally, I think this here works better. Okay? And the reason why is, again, you're not being stuck with any negative indices here, so therefore you don't have to worry about plugging in a negative when you're doing your calculations. So we've now found the point where we've got our gradient. We now want to find the tangent when x equals 0. So when x equals 0, we know that anywhere we have an x, we're going to plug a 0 into it. So anything that is to a power of 0 is always going to be 1. So if we rewrite our answer just over here, what we're going to have here is we're going to have negative e to the 0 all the way over 2 minus e to the 0 all squared, which then gives us 1 over 2 take away 1 equals 2 squared equals 1, 1. So your final answer here is negative 1. So what we've looked at in these questions here are different ways that you've learned how to do differentiation, but now we're doing it in terms of logarithm, exponentials. Really important to remember that this rule can be mixed up quickly. One thing, remember, it has to be e to the x. If it's e to the negative x, then we're doing this type of calculation here. Alright, good luck with this, and I'll see you in the next one.